Students, in this video, we are going to look at the use of arithmetic operators in C, and we will look at the limitations of using int boxes for doing these arithmetic operations. So, the code here should be familiar to you if you've been practicing your programming. Here, we take two integers as declarations, first and second numbers. Then we scan these inputs from the standard input. And then we already saw how to add these numbers and print the output in week 1 of S111 with the same basic principle, but with the use of the minus operator instead of the plus operator. We can print the difference between these numbers. So if you want to do the first minus second, or you want to do the second minus first, you just have to change the order here. Then, if you want to find the product between these numbers, this asterisk is the multiplication operator. Now, this is new to those of you who are new to C. So be sure that you remember this. Don't try and use X for multiplying. It is the asterisk sign that is C's operator for multiplication. And the use of this operator here multiplies the first number with the second number and prints the product. Then next, you will notice that I am saying the quotient between the numbers is %d, and this operator is not in fact the operator to find the quotient. The operator is the divisor. This is what you use to divide the first number by the second number. But because the output of these numbers is also going to be of type int, therefore it will not be an exact division. The decimal part of the division is going to be lost in this operation, and therefore you are going to see just the quotient between the numbers as the output, and that's why I have written the print format string to read the way it does. And then finally, this is also a little bit unique. The remainder between the numbers, where when you divide the first number by the second number, the remainder that you get is first, then the percentage sign, and then second. So notice here that the C compiler is contextual. The use of the percentage sign is interpreted in the context of the other literals that surround it. It is not the case that the literals are interpreted in a context-free manner. And this is meaningful for you when you go on to study different hierarchies of programming languages in some more advanced computer science courses in coming years. But that's not where we are going right now. Right now, we are just going to look at the behavior of this code, and we'll make some small modifications to see how we can change that behavior. So let's look at some possible inputs, and let's see how this code works. So we'll just enter some small numbers to begin with to test it. The sum of the numbers is 10. The difference between the numbers is -2. The product of the numbers is bizarre. Why is this? Well, it's because of some experimentation that I was doing off screen that I will show you momentarily. But let's just fix this here. So the sum of the numbers is 10, the difference is -2, the product is 24. Look at the quotient is 0. So if you try to divide 4 by 6, using integers as your variable boxes, you can only get 0 as the output. This is something that can cause a number of subtle logical errors in your code, because you may say, I want to divide first by second and multiply the whole thing by a third, and by the rules of BODMAS, division should happen first and then multiplication. But what will end up happening is that you'll divide 2 by 3 and try to multiply the whole thing by 6, and you'll expect that the answer should be 4. But what will happen is that 2 will divide by 3 first and give you not 0.67, it'll give you 0. And that 0 multiplied by 6 will pull the whole expression down to 0. This is a very common problem, and you don't want this to befall to you. So very soon we will be moving to data types in C that are a bit less restrictive than int, and then we'll be able to do division properly. But in the meantime, let's try a slightly different value of these numbers. So this time I'm going to say 1400 and 1000. Okay? And again, you can see that the sum prints out well, the difference prints out well, the product is relatively bigger, it's 1,400,000, and it prints out reasonably well. And the quotient and the remainder are also decent. So everything is fine. But now let's push this still further. Let's say I have 14,000 multiplied by 100,000. Now, in this case, you can see that the difference is negative, and that's fine. The computer gets it done. The quotient is again 0, and the remainder is again correct. It's all reasonable. Now, where am I going with this? Where I'm going with this is here. Let's say I take a number this size, 2 lakhs multiplied by 1 lakh, or 200,000 multiplied by 100,000. Now, what do we expect will happen? The sum is fine, it's 3 lakhs. The difference is fine, but the product is now completely wrong. Now, this doesn't make sense. Why should the code work for small numbers and break for big numbers? This seems to be a bit of a mystery, but it's not really. And this is the point where we'll jump off and start talking about the reason that we want a greater selection of data types than just int for doing math using C.